Using the Pythagorean Theorem. You can use the Pythagorean Theorem to find the length of a side of a right triangle when you know the lengths of the other two sides. Example 1. Find the length of the missing side. Okay, so whenever you are using the Pythagorean Theorem, of course, you want to write your formula. A squared plus B squared equals C squared. Before you ever go and plug numbers in, you want to label where is A, B, and C on your triangle, okay? So A and B always have to be attached to this right angle, okay? So it doesn't really matter if I make the 7 the A or the B. I just have to start. So here 7's going to be A. This side down here that is helping form that right angle, label it as B. And always point the arrow away from the right angle and label that as C. The C has to be across from the right angle every time. Okay, so once I've written my formula, and it is on your chart, and I've labeled A and B beside the right angle, and C is across from it, then right underneath the letters, you want to fill in that number, okay? So for A, I had a 7. The formula had a squared on it, so I got to keep it and bring down that plus. The number that I had labeled by my B was 24. It has a squared. I'm going to bring down that other side. There's not a number out here. I'm trying to find the C, so I'm going to leave that as C, okay? Now, this part of work is all on the left side of the equals, so I am going to use my calculator to figure out whatever that is, if you can see it. Okay, what was it? 7 and 24. 7 squared plus 24 squared says 625. 625. Okay, so I worked all this side, okay, and I bring down this. Now, I'm trying to figure out some number times itself, because that's what a squared does. Some number times itself is 625. So the opposite or the inverse operation of a squared is going to be to take the square root. Okay, so I've got to take the square root of 625. So I'm going to hit the blue button and where it says x squared and type in my 625, enter. I get 25. So it says the length of the hypotenuse, because I was missing the longest side, is, kind of ran out of room, let's say 25, and this had inches. I'm going to put it on there, just like that. Okay. The last thing that you always want to do whenever you're solving a problem with the Pythagorean Theorem, you want to check to see if your answer makes good sense. So I'm going to put it on my picture. Remember that across from this biggest angle, the right angle, that has to be the longest side because that's the side that is the most open, okay? So it has the longest length across from the biggest angle in the triangle. So you double check to make sure that your answer for C is bigger than that side. So yeah, 25 is bigger than 24. 25 is bigger than 7. So yes, I was solving for the longest side and I got a number that was bigger, okay? So that lets me know it does work, okay? Next, on B, I have a right triangle and I have two sides. So anytime that you have a right triangle and you have two sides, you can use the Pythagorean Theorem to solve for that missing side. So you start with your formula, a squared plus b squared equals c squared. After you write your formula, you want to label A, B, and C on your picture before you go plug in numbers, because I do not want you to plug them in some crazy place, okay? The sides that are forming the right angle will always be A and B. It doesn't matter if I would have made the 12 the A and then this side over here B, completely fine. I'd get the same answer, okay? But I do always have to go across from the right angle and make that biggest side C every time, okay? So now I've got my formula. I've got A, B, and C on there, so I can go plug in. I don't have a number by A, so I'm leaving that A squared. By B, it says 12. I have to keep the squared that was in the formula. This time I have a C, so it says 15. Keep the squared. Okay, this one's a little bit different because before, whenever I had both of the legs, I was able to type all of that in, okay? But this time I only have this part to type in. But most of you know, 12 times 12 is 144. So I only have that part to work on this side, okay? So I did it. I brought that down. 15 times 15 is 225. Okay, so I can't add them together because this equals is in my way, okay? So if they're on different sides of the equals, you cannot add them, all right? Now keep in mind what we're trying to do. We're trying to isolate this A squared. So you treat it just like an equation that we just revisited last week. I've got a positive 144 right beside my variable. I do not want it to be here, so I have to give it something to make it go away. So since this is a positive number, a negative 144 would help it cancel. I'm going to do that minus 144 on the other side of the equation. So you cancel out your zero pair. So over here now, I'm one step closer to solving it for A, because now it's just A squared equals, how much is that? 6, 7, 8, 81? Okay. So this says A squared equals 81. So it's saying a number times itself is equal to 81. So whenever you want to undo a squared, you do the squared root of both sides. So that will just leave me with A equals 9. Okay, so the length of the leg is 9, and this picture had centimeters. Remember that you want to go back to your picture to see if that's an okay answer. So if I had 9 centimeters over here, remember since this is a leg, the number I get for a leg should never ever be bigger than the hypotenuse number. So since 9 is smaller than 15, that makes it an okay answer. So box that in.